Hi, in our previous videos we have learned to identify the graphs of degree 0, 1 and 2, and we also know how to draw them. In this video we will see the graphs of polynomial functions which are of degree greater than 2, and we will see that these graphs, they do not follow an easy to determine pattern as graphs of degree 2 or less. So we will look at the basic features of these polynomial graphs which are of degree greater than 2. So the general or the most basic polynomial function can be represented as y is equal to x to the power n. It can be represented by a monomial x to the power of n. We have to look into the graphs for which n is greater than 2. When the degree is greater than 2, n is nothing but the degree of the function. The highest power of the function is called its degree. So now when n is greater than 2, then let us see how our polynomial graphs look like. We will be considering the simplest of polynomial graphs, x cube and x to the power 5. Okay, so we will see first the graphs of x cube and x to the power 5 where n is odd. Okay, so let us try plotting these two curves. This is the graph of y is equal to x cube. What do we see here? That the graph is continuous. Okay, there is no break in the graph. And there are no sharper pointed turns in the graph. The graph is smooth throughout. One more thing which we see about this graph is that the graph is more of an S-shaped graph. Correct? And it is touching the x-axis at the origin, which is 0, 0. Now let us try plotting y is equal to x to the power of 5. The black graph is x to the power 5 graph. In this graph also we see that it's a smooth curve. There are no sharper turns. There is no discontinuity in the graph. It is passing through the origin. It is touching the x-axis at origin and it is again S-shaped. If I try to plot y is equal to x to the power 7, I am plotting all the curves, polynomial functions which have got odd power, which have got the odd degree. So here again I see all those properties of the graph. So we see that it is a continuous curve, continuous graph. There are no breaks in between. Okay, it is smooth and rounded. And the third property is that it is S-shaped. If it is in the simplest form, then it touches the x-axis at 0, 0. Correct? Now let us see graph of the polynomial functions which have got even power or even degrees. So y is equal to x to the power 4 we will see, and y is equal to x to the power 6. Let us try plotting them. X to the power of 4. Okay, we see that the graph is U-shaped, graph is smooth and rounded, and the graph is continuous and it is touching the x-axis at origin. Okay, let us try plotting y is equal to x to the power of 6. Again we see that the graph is U-shaped, a little broader U. The graph is touching the x-axis at origin, smooth and rounded and continuous. Okay, so we see that the general feature of any polynomial graph of degree greater than 2 is that it is continuous, which is there for both even and odd degrees. The second common property which we saw was both are smooth and rounded, and they both touch the x-axis at the origin. These three properties are same for the basic polynomial graph y is equal to x to the power n when n is greater than 2 and whether it is odd or even. But the only difference is that when n becomes even, then the shape of the graph changes to a U. It's a U-shaped graph. Okay, so by looking at the graph, we can tell whether the degree of that polynomial function is even or odd. If it is a U-shaped, it is definitely of even degree. If it is an S-shaped, it is definitely an odd degree function. So I hope the general features of a polynomial graph is clear to everyone. In our next video, we will see how do we perform the leading coefficient test for a polynomial graph. If you have any doubts regarding this video, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel Mathacademy. If you have liked my videos, please don't forget to like, share and subscribe. Thank you.